Hi, I'm Steph McAfee, the Nevada State Climatologist, and I wanted to talk today about the impacts of climate change for us here in Nevada. Much of the information I'm going to show you today was developed for the State Climate Initiative by a team of scientists at UNR, DRI, UNLV, and UC San Diego. And none of this work could have happened without the contributions of everyone on this list. If we take a big picture view, we can see that global average temperatures have been increasing. And worldwide, the 5 hottest years since the late 1800s have happened in the last 6 years. And the 10 hottest all happened in the 21st century. And we're pretty sure it's us. When we take state-of-the-art climate models and run them with everything we know that could have influenced climate over the past century or so, including our emissions, we get a picture like you see over here on the left. Now that sort of band of orange shading is the range of results that climate models tell us about, and the green, red, and black lines show us the actual observed temperature. And you can see there's a pretty good fit. When we account for everything we know about, the models simulate a temperature change that's much like what we've observed. When we take ourselves out of the picture and run the models again, we get something like we see over here on the right. Now in this case, we still see those sort of bluey green, red, and black lines showing the observations. But in this case, when we don't tell the models about our greenhouse gas emissions, they simulate temperatures within this blue band. They simply can't simulate the increases in temperatures that we've observed without accounting for our greenhouse gas emissions. And these changes are going to continue as emissions continue. And how much change there is in the future will scale with the amount of emissions. Higher emissions, like in this brownish RCP 8.5 high emissions scenario, mean bigger increases in temperature, as you can see over here on the right. Lower emissions, like in the RCP 4.5 or even 2.6 scenario, mean smaller temperature changes. So what does this mean for us here in northwestern Nevada? Well, if we look back at water year precipitation here in northwest Nevada, we really don't see any change in precipitation amount over time. Looking back, we see really wet years, really dry years, runs of a few years when it was pretty wet, and runs of a few years when it was pretty dry. Now, when we look to the future, northern Nevada might get a little bit wetter. Right? You can see we're looking at changes in the near term of maybe 10 or so percent, perhaps smaller increases in precipitation as we get out towards the end of this century. And in northern Nevada, models mostly agree that precipitation will increase. But there are a few models that are just as good as any of the other models that suggest precipitation in this area might decrease a little bit out towards the end of this century. Now, we know for sure that temperatures are increasing, and we can see that very clearly. This is showing you the annual average temperature for the water year. And what you see is that there are more and more really warm years, and that even our cold years aren't that cold anymore. And as we move into the future, average temperatures will almost certainly increase. Probably 4 to 6 degrees Fahrenheit over most of the state by the middle of this century. By the end of this century, we're probably looking at temperature changes anywhere between 6 and maybe 10 degrees Fahrenheit, depending on where you are and on whether emissions are on the lower side in this RCP 4.5 scenario or higher in an RCP 8.5 scenario. And now here's a really important point, is that irrespective of what happens with precipitation, whether it stays the same, increases a little, or decreases a little, warming alone will cause more drought, more flooding, and more wildfire. It will also mean more really warm days and nights that we need to contend with. Now, we already know that Nevada is a dry state that also experiences drought. And we're currently in the midst of what looks like it's shaping up to be a pretty bad drought. So, how does increasing temperature cause drought? Well, as temperature goes up, all else being equal, things dry out faster. And what we can see here in this map is that as temperatures have increased, evaporative demand has also increased. And evaporative demand is just a fancy way of saying how much water does the atmosphere want? And of course, when we have greater evaporative demand, we tend to see increased irrigation and outdoor watering needs. And so the increases in temperature over the last century or so have also driven increases in drought. You can see that here with the increasingly negative Palmer Drought Severity Index values. Now, because we expect temperatures to increase in the future, we also anticipate that evaporative demand will increase into the future. So we'll see an even greater influence of drying. Irrespective of any changes in precipitation, it will simply be easier to dry things out. Now, warming also means that less of the precipitation we get will fall as snow and more will come as rain. Now, across the West, and definitely here in Nevada as well, we use the snowpack to supplement our reservoirs. It's kind of like extra storage that we didn't have to build. So a shift from snow to rain means less water storage for the summer, even if the amount of precipitation we get stays the same or increases a little bit. And when you combine that reduced storage, so reduced water supply in the summer, with the likelihood of higher evaporative demand, so greater water needs during the summer to maintain crops, you can see that we're probably looking at some pretty significant stresses on our water resources. But conversely, higher temperatures may also mean more frequent or more severe flooding, or perhaps both. And while that shift from snow to rain might reduce our snowpack, leading to reduced supply in the summer, it can also increase our chances for winter flooding. Right? We have more potential for rain on snow events, something that leads to pretty substantial winter floods now, but also the potential for just full-on rain events during the winter leading to flooding. Now, that same process that causes warmer temperatures to dry things out faster also means that warmer air can hold more water. So, as it warms up, storms can be more intense and can bring heavier precipitation during that storm. So, this means we might see really heavy rains during the winter, or we might see particularly heavy snowfalls that could then melt. All in all, this shift from snow to rain, coupled with a warmer atmosphere that can hold more moisture and bring us more intense storms, means that there's the potential for both more and more severe flooding. And you see that in these maps here. They're showing potential changes in the peak daily runoff. So what's the most amount of water that could come off the landscape? And you can see that it's increasing across almost all of the state, whether we look in the near term or further out into the future. And some of the biggest increases are happening here, right on the lee side of the Sierra. We also expect that as temperatures increase, there will be more wildfire. So warmer temperatures and a snowpack that melts out earlier can both contribute to an increase in wildfire. Now, the earlier the snowpack melts, the sooner fuels start drying out, so the fire season may be able to start earlier in the spring than it has. Warmer temperatures overall, of course, are also going to lead fuels to dry out more and faster during the summer, so that our forests, our grasslands, our sagebrush could all be more flammable in the summer. And these kinds of things may already be happening. This is showing the results of a study from a few years ago where the authors were able to estimate the impact of climate change on how much forest burned in wildfire. And they found that had there not been any climate change, we would have burned probably about 10 million acres of forest between the early 80s and 2015. With the climate change we've already experienced, that total was in fact more than 20 million acres. And the overall drying also means that we expect seeing an increase in the number of those really hot, dry, high fire risk days. Particularly, as you can see, by the end of the 21st century, in and around the Truckee and Carson basins. And this increase in fire risk isn't just limited to Nevada. So we're looking at both the direct risks from wildfire, damage to property, infrastructure, to life and to health and safety, but also some of those more indirect risks. Say, decreased air quality from fires in California, something that we're already dealing with it seems like increasing frequency. And of course, as temperatures increase overall, we'll have to deal with more extreme heat as well. There will be more very warm days and nights, particularly in the lower elevation parts of the basin. Now, the Carson Valley isn't going to face the degree of heat that someplace like Las Vegas is, but increasing daytime temperatures do pose risks to people working outdoors. And many houses in this area really weren't built to deal with the heat, especially the nighttime heat. So people may need to start thinking about modifying their homes to deal with this, adding AC or making some other changes to deal with temperatures that just don't cool off as much at night. So what does climate change mean in Nevada? Well, it's going to mean planning for more and more extreme versions of the climate challenges we already face. More extreme drought, more extreme and possibly more frequent flooding, more wildfire, and more extreme heat. And so if you have any questions, I'm happy to take those later in the panel. Thank you very much for listening.